Welcome back. We'll continue on with this polar coordinate stuff. So we just introduced them, so now let's go over how to convert them back and forth between the two systems. All right, so let's go from rectangular to polar. So we're going to be working with x's and y's, and you're trying to get it into r's and thetas. So if you look at this triangle, there's an equation or a little famous theorem that would relate x, y, and r together. And that's because this triangle has a base of x and a height of y. So for your first conversion formula, if you just used the Pythagorean theorem, that would relate these three variables together. So you can leave this alone the way it is. So if you ever see an x squared plus y squared, and you're trying to get to polar, that would be an r squared, and vice versa. Or if you had an r and you wanted to change it into rectangular, you could change it into root x squared plus y squared. So you can go off of either one depending on which one is most practical for you. Okay, and then the second one is going to deal with the theta. So since we're talking about an angle, that means we need a trig function to relate the angle to the sides of your triangle. And a good one to use would be tangent. You could use cotangent if you really wanted to, but typically it's tangent. So tangent of theta equals y over x. So theta would be inverse tangent or arctangent of y over x. Now, inverse tangent, it has its own special little domain and range. So any answers that come out of an inverse tangent are going to go from negative pi over 2 to pi over 2. Well, that might not be where your theta actually is. So you just want to make sure you're in the correct quadrant. And it's usually pretty easy to tell, and it's easy to fix in case you're not. All right, let's go from polar to rectangular. So now you're going the other way. Now you're dealing with r's and thetas, and now you're trying to get into x's and y's. So you could use this one if you want, but typically the one that's or the two that are kind of standard are these. So the first one would be x equals r cosine of theta, which does seem kind of random, but it's really not, because you're just using SOHCAHTOA with that triangle that we have over here from our little diagram. So if we did cosine of theta, that would equal x over r. So if you multiply the r to the other side, that's how you get x equals r cosine of theta. So in a similar fashion, instead of using cosine, you could use sine, because that would just use the y, theta, and the r. So if you set up something similar, you could solve for y and say it was equal to r sine of theta. So let's go ahead and try these out. So example 3, find the rectangular coordinates of each point. So let's look at the first one, because sometimes you can kind of cheat. Negative 3 pi, if you actually try to plot that, you would be on the third ring. So pi would be over here, but the negative on the 3 flips it back. So you're actually located right there. So on a rectangular coordinate system, that point, like you just went over 3 to the right and you didn't go up or down. So that would just be 3, 0. So sometimes you can cheat. So like if it lands on a coordinate axis, So like at 0, pi over 2, pi, 3 pi over 2. Just give the coordinate in rectangular form, and then you've got it. If you forget, you can always go back to these or these and just plug them in. So like for B, let's go ahead and use the formulas. So we're going to use x equals r cosine of theta. Your r is negative 2. Theta is 2 pi over 3. And then you just evaluate. So negative 2 stays cosine of 2 pi over 3. Well, that's a negative 1/2. If you multiply them together, it gives you 1. So then for the y, you're using r sine of theta. R is negative 2. Theta is 2 pi over 3. And evaluate it. So it's sine of 2 pi over 3, root 3 over 2. So negative root 3. So that means your coordinate or your point would be 1 comma negative root 3. Okay, so let's go ahead and try example 4. And sometimes, again, you can cheat. So like 0, negative 2. That would just be straight down by 2. So if you plotted it on polar, it's going to be in the exact same location. So the r has to be 2. And the theta, you could do a lot of different ones, but if you just went in the positive direction, 3 pi over 2. I mean, if you wanted, you could do negative pi over 2. I mean, there's a lot of different ways you could use for the polar, because remember, they're not unique. So that makes your point 2 comma 3 pi over 2. Okay, so let's do part B when it's not one you can really cheat with. So we're going to be using these guys right here. So the r, that's equal to root x squared plus y squared. So take your two coordinates, square them both. So 9 plus 9. So r comes out to equal 3 root 2. Now for the theta, inverse tangent of the y over the x. So it's inverse tangent of negative 1, which if you just evaluated it with the inverse tangent, that gives you negative pi over 4. But this is not in the quadrant that we want. Negative 3, 3 is in quadrant 2. This is in quadrant 4. Well, they're going to share the same reference angle. So that's still pi over 4. So we just need to rotate it around from quadrant 4 all the way to quadrant 2. So the theta we want to use with that same reference angle would have to be 3 pi over 4. And there's your point. Okay, in the next video, we'll go ahead and look at some equations, and that will be it for 9.1. So check that one out.